Good morning, everyone, and welcome to our webinar on innovations in smart water. So I'm Mona Arnold. I work as a principal scientist at VTT, and here in the next hours we will give you a glance into the recent developments in smart water management. We will have some solutions introduced by the companies Pipelife, Keypro, and Elisa. And then we will finish up with how VTT's presentation on how to identify weak signals and how to interpret them, what that would how to predict, what that would mean for predicting what will be the future trends in smart water management. Next slide, please. So the context here was a project funded by Business Finland together with Nokia on enhancing water utilities operations, which I was happy to coordinate. Please go forward. And it was an innovation ecosystem consisting of 9 companies, large companies and SMEs, 2 research organizations, VTT and Savonia, the University of Applied Science. We were followed up by also the number of utilities followed up the project together with their organization, the Finnish IWA, and then we had Finnish Water Forum for the market research. The motivation for the project, please forward, was the challenges that the water distribution networks are facing. Next slide, please. The water distribution network is extremely critical infrastructure. It needs to be safe, it needs to be secure, both physically and also from the data transfer point of view. It's also the most expensive infrastructure in our society. And with all the pumping, it's very energy intensive. Next slide, please. So the utilities are today facing quite a few challenges for smooth operations. They need to reduce the water loss. Comes from the fact that much of the infrastructure is quite old, some of them more than 100 years old, and they are situated underground. And as a matter of fact, almost 30% on a global average is lost on the way before it reaches the household. That's 126 billion cubic meters. And if you think about it, like a water cube, it has a side of 5 kilometers. The energy consumption is high, and it leads also to quite high operational costs. And at the same time, the water utilities need to ensure that the water quality is correct when it reaches the households. Next slide, please. So in this innovation ecosystem, we developed and tested smart water solutions to develop tools that would enable the consistent decision making for the utilities. It contained advanced digital water metering, control of non-revenue water, assessment of online water quality monitoring systems, and so forth. One quite important aspect, next slide please, of going digital, when I say putting in meters in the network, is the energy efficiency of data transfer. When you put in a meter in underground, you don't want to go there every 6 months to change the batteries, but it's really important that it will stay there and give correct readings for, let's say, the next 10 years. And here, the energy efficiency of the data transfer comes into play. So in the next 5 minutes, my colleague Olli Apila will tell you something about the work that we did for providing guidelines for energy efficient smart water device deployment. Thanks.
Okay, thank you, Mona. I'm Olli Apilo from VTT, so I'm Mona's colleague, and I'm going to briefly tell you about the cellular IoT for smart water applications. So many smart water applications rely on meters and sensors collecting information about the water network status. Their main connectivity requirements are low energy consumption, because the devices can be operating on the batteries of the electricity grid, and also long communication range, because the devices are often located underground. On the other hand, the data rate requirements are modest, allowing low-cost connectivity solutions. These requirements are tackled by low-power wide area network technologies, including LoRa and cellular NB-IoT and LTM. The benefits of these cellular LP1 technologies are the good level of security and quality of service when compared to the unlicensed spectrum technologies. After a slow start, the number of cellular IoT networks and subscriptions are steadily growing, making them future-proof solutions. Both NB-IoT and LTM are suitable for smart water applications. The main differences are that NB-IoT is more energy efficient for small payload data, while LTM has higher data rates with support for device mobility, if that is needed. Next slide, please. Although cellular LP1 is designed to be very energy efficient, battery lifetime of over 10 years can only be reached by very careful design and planning. I'll now give you a few guidelines how to maximize the device battery lifetime. NB-IoT and LTM have several energy-saving mechanisms, including release assistance indication, extended discontinuous reception, and power-saving mode. These should be selected case by case to match the application requirements. For example, if the data transfer is one-directional, only from the device to the cloud, the minimum energy consumption can be reached by releasing the connection immediately after the data upload using RAI, and then entering power-saving mode. With this kind of operation, the device is not reachable from the network side, but as you can see from the figures on the right, the power consumption becomes minimal when not transmitting. There are also other ways how the energy consumption can be minimized. For example, if possible, try to avoid device locations with high path loss, use data buffering as much as the application allows, and transmit larger payloads at a time. And finally, choose the technology carefully according to the payload size. At some point, for example, this LTM starts to consume less energy than NB-IoT as the data payload size increases. You can go to the next slide, please. One practical issue when designing a smart water application is that the battery lifetime prediction using the module data sheets and power consumption models is not very accurate. So a good approach for such battery lifetime prediction would be then to implement a prototype software to the device and then measure its energy consumption in an environment where all the relevant factors can be controlled. This can be done, for example, at VTT's test network, where different network configurations, different connectivity modules, and different protocols can be compared. Our test network hardware and software are similar to the ones used by the commercial operators, and we can change the network configuration freely as required by the test scenarios. At the moment, we have several frequency licenses for testing cellular LP1 at frequency bands from 450 MHz to 2.1 GHz. And it's possible to measure the energy consumption using accurate current profilers that capture also the fast variations in time. As a final note, I'll mention that the test network capabilities we have are not just limited to LP1, but it's also possible to test more capable connectivity technologies, such as 5G new radio, also at the millimeter wave frequencies. Okay, you can go to the next slide, please. So thank you from my behalf. Next, Marko Heikkinen from Pipelife will tell us about Pipelife's journey to global solutions. Thank you.
Thank you, Olli. I'm Marko Heikkinen, currently located in up north here in Norway, so therefore the saving the bandwidth course and only heard by audio. I'm coming from the Pipelife International or a European-based traditional piping and water transformation solution provider, but we have a branch of smart solutions as well, and I'm heading the business development operations for that in the north. And here's a few insights about us and from our perspective that how we will able to achieve and create global solutions based on the SWIM project and based on the Finnish smart water community or smart water network. Next slide, please. So in our company terms, we are typically familiar from the traditional business side or from the traditional network asset side, but we see it also as a strong foundation of bringing different verticals. Typically, the smart water solution providers, they are able to provide for the platform for the end-to-end connectivity and collecting the data from the assets down in the ground. Then they provide a cloud monitoring and controlling platform, and then they provide a platform for insights and analytics similarly as us. So basically, we have a plus 500 customers in Europe for the smart water platform and plus 400 energy companies on our platform that we provide services. We provide the end-to-end connectivity from our network assets that we manufacture. We make pumping stations, for instance, or our competitors, or our solutions can be based on agnostic of the different automation manufacturers, for instance. And in the next slide, we are able to see that how our journey went in one of our development projects globally in the SWIM project. So our ambition started for specific sensoring area for structural electronics. We wanted to also focus especially on the integration and manufacturability for our asset products, and of course building the development network and building a integration for the Finnish and the European smart water developing ecosystem. We also seeked for improving our own knowledge base around that theme. So what we did and what we were able to accomplish during the project time, of course, the aims and the realization tend to divert a bit during the network developing. That is rather natural, and that happened for us as well. So for the Smart Hub, we were able to focus for our probing solution, so integrating our non-intrusion sensor integration method for the test bed, and also integrated for our smart monitoring and controlling platform, and then and start building solutions based on that. We improved our smart pumping solution in the project, and as a bit of a surprise also for us, or the simplest solution that came closely as a side project within the project turned out to be the most important one, at least in terms of the global solutions for us. So the smart level solution, a close collaboration with a Finnish sensor house, turned out to be the most interesting from our perspective. As a result, for our joint collaboration, we were able to achieve 2 to 3 new or improved solutions in the domain of smart water management, mainly on the areas of the smart pumping and based on the level metering, and also we built and we were able to create rather finished supply network out of those solutions for a global solutions. And the development during the project continues as an enable as we speak. So based, for instance, in one of the development tasks or the work packages that we did in our project, we were able to continue to non-revenue water, for foreign water detection applications, and we continue to develop in collaboration, of course, with the existing network that we have developed, and also there were certain aspirations during the project, for instance, among the other participants that Mona showed in the network, and the discussions are still going, even though the calendar time the project ended for us, but the development itself continues. So we will, and we are using currently the SWIM project as an enabler for our future sensor solution and collaboration network development. Usually in these projects we seek a global results, or we seek for internationalization possibilities, and in the following slide you will able to see the picture of today. So we did some piloting during the project for some of the applications. The pilots, of course, were easy to conduct in the close countries for Finland and for Austria and for Norway, but the commercialization has been initiated, and the solution based on the findings and based on the developments that we have done during the project are now going on in these countries. So we have additional installations and real beyond the pilot customers also in Austria, in Belgium, and in Croatia, in Czechia, and all over the Pipelife network countries. So it was, even in the hindsight, a bit of a surprise for us that how easily the actual commercialization were able to take place, but of course we had to take that into consideration already in the beginning, try to focus on a bit of a simplified version of the actual solution developments, and then expand on the more challenging ones later on, and of course the ability to integrate for our known core platform helped for us to reach these targets. But that is a short glimpse of how we did it, how we developed a few smart water solutions for us in collaboration with a Finnish smart water ecosystem. And if you want additional questions or comments, please, of course, contact personally, or we can continue the discussion in the Q&A session. And thanks from Pipelife side, and Noora Liliento will continue to share thoughts about their experiences, and Noora will tell more about Keypro Smart Network Management. Thank you.
Thank you very much, Marko. That was a good overview. So my name is Noora Elisa from Keypro, and my presentation is about Keyaqua point of view. And Keyaqua is a network information system for water utilities. So it's basically GIS map where water utilities can manage the network assets and manage the condition of the network. And my topic today is the network management from GIS point of view and how we have made it smarter in this SWIM project and in the previous years. So let's start. First, about the challenges that water utilities currently face when they think about the network management. The three first challenges are about data management. So it is a great challenge with water utilities that they have a lot of data from the field and in the systems, but it's scattered. And it's very difficult to find data from multiple sources and to understand the big picture. So there is data, but it's hard to understand what the data can tell us. And data transfer has been quite normal between systems for many and tens of years, but there is still a lot of manual steps needed in order to smoothly transfer the data. So there is some optimization potential in the data transfer between solutions. And then two great challenges that Mona was also referring in the introduction is about the infrastructure and the need for making sure that the infrastructure is in good condition. So the renovation depth is increasing and increasing. Water utilities have a lot of hidden network behind the ground, below the ground, and they need to prioritize the renovations. And water utilities need to prioritize the renovations, but there is not enough information available to do that. So these are the great challenges that water utilities had before the project and still have. But in the next slides, I will give some examples of how we helped together with partners in this project. So like I said, that water utilities have a lot of network and they need to make sure that it managed in optimal way. And we in Keypro see that the network management, it actually is about data management. So it's about technical things, but it's also about data utilization. So it's about the people who use the data. So it's both technical and user-oriented challenge. And solution need to also to be taken into account, both the technical and the user aspect. So when we think about the smart network management, and what we did in SWIM was that all the stakeholders need to access the data. And in order to do this, first you need enough data. So first you need to collect the data. And here you need different partners to collect the data. And then next step is to transfer the data smoothly between systems. So first you need to collect the data, and then the data needs to flow smoothly between systems and solutions. And the next step, after the data is already moving, then you need to take the people into account, and then you need to visualize the data and to transform it to a format that the users easily understand what the data actually means. And then you can utilize the data. So all these aspects were taken into account in this SWIM project. And a very important aspect in this project and in smart water in general is the cooperation between different companies and different solutions. And I always like to say the phrase that cooperation needs to be not only in PowerPoints, but also something more practical. And it's something that I mean that when the real cooperation exists, it's real transfer of data from system to system and real understanding of the user needs together. And how how this was done in the SWIM project. One very important aspect is this API. So it's technical way to transfer the data online between solutions with no delay, so that the data and information is available for everyone. And it also needs the continuous development. So you need to start from somewhere, and together with partners and users, go step by step forward. And next, some more practical examples. So like I said, that first you have data, and then you need to play with the data and transform the data so that it can really help. So first data is data, then it's information, then it's knowledge, then it's understanding, and only then it can lead to different kind of decisions and different actions. So it means that the data needs to be transferred for user before it can really help and relieve in the everyday work and give some savings. And here are some practical examples in the context of this project, that how after SWIM things are easier when the data transfers between solutions. First example is that engineer wants to see network map in the background of their automation system to understand what kind of area is affected if they change something in the automation. So this is now easier than before. Second example from user point of view is that GIS engineer wants to understand their network condition better and to prioritize renovations. So now there is better analysis tool and more data available for this kind of analysis. And then third use case example of the project is that planning engineer wants to do hydraulic modeling, and then after that they want to show findings for their colleague. So they don't need to send any files through email. Instead, they can just refer to some layer in their GIS, and everybody can see what they have been doing. And then last example of a use case, what is now easier is this kind of figures, key figure and reporting example. So example is that manager wants to report key figures and report, for example, to owners or decision makers about trends. So when API is between solutions, this kind of data transfer for reporting is also a lot of easier. And then the next slide, please. Yeah, you can show all the photos at once. Thanks. One more. Yes, thank you. So this is what I already explained, but one more practical aspect and some screenshots also. So like I said, that in this project we did some enhancement for our analysis tools about leak water and renovation prioritization. So first example is the water balance calculation, and the screenshot on the right hand side. So this analysis tool is for users to identify where are the most leaking areas. So this is one practical example of data transferred to an easily understandable format for users, and this requires data transfer but also the user experience analysis. And then the second example is from hydraulic modeling point of view, and here our partner in the project was Fluidit, and the screenshot on the left hand side. So in this example, hydraulic modeling is not new, but it is new that the data flows smoothly from GIS to modeling and then back to user in the GIS. So it allows all the stakeholders to access the information. And then the third example is like the general aspect of the data export via API. And one example is in the image in the center. So we provide data from GIS to use in the background in, for example, SCADA or some BI solution or anywhere where a user need it for some other reasons than in GIS maps. Okay, so this was summary of the practical steps that we have done in the project. So then one more slide about the summary. So when you think about smart network management, the goal is always how can water utilities save water, save time, save money, and save energy and save nerves. And we see that it happens if the data first goes between the solutions, then the data is for the users who actually need the data, and when the data is in a format that is easily understandable for the user. Yes, and then the next slide, please. Yes, thank you very much. That was all for me today. And please don't hesitate to write any questions to the chat. We can reply later in the QA. Thanks. Okay, and then I leave the floor for the next presenter, who is Taavi from Elisa. Thank you very much.
So my name is Taavi Mattila. I'm a business lead of Elisa's IoT connectivity. I believe Elisa is pretty familiar company to all the audience, but we are the biggest mobile operator in Finland and the second biggest one in Estonia. We were taking a part in the SWIM project as well, and I'll go through briefly how the ecosystem looks from an operator's point of view that's not really building a own solution to help water utilities, but being part of many of the solutions that are being built in the ecosystem. So first few slides about challenges and possibilities, and then one slide about what we have done, and I'll try to briefly go through how we see the situation. Many of these topics has been raised out here already, but I'll repeat them and tell our point of view of those. So the first one is that the digitalization is really changing the utility sector and especially water utility sector right now. And we are seeing quite a lot of similar things that happened like 10 to 15 years ago in Finland for electricity networks when smart metering was implemented in electricity, and that caused like services offered to end customers and individual inhabitants to raise to another level, and I really believe this is going to happen for water utilities as well in the coming years. But there's a lot of data available as was mentioned before, and Nora said it as well, and it enables a lot of different things. So you can build new business on top of the data. You can enhance your operational efficiency. You can be more sustainable, and you can build better end user experience either for your own customers or your customers, end customers, or you name it. But the big challenge here is that the water utilities are quite traditional businesses, and they have been doing the same things for years, and this is new for them. So the know-how there is a real challenge, like know-how in how to run IT projects, how to procure IT stuff, what should be done, how they should be done, and there's a lot of new companies coming up all the time. There's a lot of solutions available, so you need to understand what's the difference, what's the benefit of each solution, and what's the weakness of some solution. So you need to be able to compare as well. And SWIM type of projects are great for this kind of stuff. So you are able to see that what's out there, how they compare, and how they interact with each other. So interoperability with different systems is the key here, because you don't want to end up in a situation where you are solving, let's say, 10 different use cases, and that means you are out there with 10 different portals to use each day, and that will just make the daily life of the employees harder. So interoperability is really a key there. Next slide, please. So from an operator point of view, then there's going to be increasing number of connected devices in like the whole country or whole world, but also in the water network, and more and more of the network is becoming like intelligent and connected, and this really arise security concerns, especially in the current state of world, and this puts a lot of pressure to the connectivity, and it really needs to be secure. So that is the starting point, that you need to trust that if you are transferring data, it's done in secure manner. And also these are solutions that are being built for many years to come, and as it was mentioned already here, that a lot of the infrastructure there is currently pretty old, and the goal is that the infrastructure that is being installed today is going to be old at someday, maybe not as old as it's today at some parts of Finland, but anyway, we need to find solutions that are future proof, and they need to be supported, and they need to be there for many years to come, at least 10, 15, 20, you name it, and that also is something that needs to be considered when choosing a solution. And then there are, like I also already mentioned this once, but a lot of different new use cases which end up in many different user interfaces and different portals, different parties to interact with, and all these need connectivity. So we play a vital role somewhere behind in the system, but we can also be kind of and as I'm talking about I'm talking about operators in general, and Elisa as a company, but we can be a clue in between, and this is how we see it also at Elisa, that we wanted to make easier to take these new services and try to make them work with each other easily, and combine data from different sources is really the key for success. So this was also mentioned here many times already. But yeah, you can go to the next slide. So what we are focusing on is making it easier to adapt new technologies. So we offer a set of solutions that will either function somewhere beneath a different system. We build services ourselves, and we take part in collaboration with many companies, and try to push all these technologies from our point of view. We can take data to Elisa from various different devices and push them to different systems via one single API. So basically we can work as kind of a data hub in between, so that the water utilities can control that which systems they are using. They can get the needed data if they are just using Elisa's connectivity. We have nationwide LTE-M and NB-IoT network. That's kind of the base of all these solutions here, and those are technologies that Olli spoke in the beginning. So we are focusing on building a high quality network there, and that is kind of our basis. And on top of that, we offer a set of modular solutions that will fit then many needs. If you need simple connectivity, you can get SIM cards from us, and if you need something more, we are able to offer data gathering platforms. We are able to operate public clouds for companies, and we are even able to build custom made software. So kind of if full stack is needed, Elisa is able to provide it, but you can only choose one part of that from us, and our goal is to just get these systems working and the data to flow to each system well, and get as many devices connected as possible. And future-proof secured connectivity is the base of all that. So we want to emphasize that at some point, if you install devices on the field that needs to be there 10 to 15 years, you will probably also face a challenge that someone finds a hole in the device's software or firmware, and it is vulnerable for attacks, and you need to do a software upgrade or a firmware upgrade. So these are things that you need to consider, that is your connectivity solution built in the way that you can do it over the air, or if you have few 100,000 devices out on the field, do you need to drive to each one of them to upgrade the firmware? So this is also something to consider when choosing a connectivity solution. So really focus on things that it's future proof, it's secure, and it's going to be guaranteed to live long there. And operators are good for this kind of solutions because our operations are regulated, and we are working on licensed spectrum that is given to us for a certain amount of time. So we are guaranteed to be there quite long in future. But that's my 10 minutes spent, and thanks. If you want to reach out, please do, or write on the chat. I'll be here to answer any questions in the Q&A session. And now over to Sajad.
Hello, thanks, Tovi. I am Sajad Ashuri. I'm a research scientist at VTT Technical Research Center of Finland. And next slide. Today I'll be talking about our collaborative work with my colleagues, Caroline Cole. She's also research scientist at the same team that I am, and I'm presenting our collaborative work on future radar signals and identification of emerging trends underwater network context. Next slide, please. Basically, our methodology relies on the larger scale data analytics based on using large language models. And the vantage point of our methodology is aiming for minimizing the intervention of the experts, and also like manual work in basically trend analysis. So the process begins with the extraction of the signals or keywords from the corpus text, which can be science data or patent data, and we use natural language processing and large language models for the signal extractions, and then we follow the signals over the time, basically how they are developed or somehow depreciated over time, according to the quantitative indicators that we constructed in this project, which are prevalence of the signal as well as dissemination of the signals, which means that like to extent which the signals are addressed in the documents or they are disseminated over different documents or textual basically evidence. And then we identify the weak signals based on their prevalency and also their dissemination index. And then we identify what are the weak signals, what are the strong signals. Basically, weak signals are referred to the signals that they have low prevalence but high growth. But for this strong signals, they are referred to the signals they come with high prevalence and high growth. And the last step of this in the methodology is the categorization of the signals, which aggregate the signals in higher level, which simplify the presentation and communication of the signals. And also it helps in identification of the most emerging area under water network context. If we go to next slide, please. So as you see in this chart, like the process begins with the data preparation. At the same time, it goes for time segmentation because we want to evolution of the signals over different period. And also extracting the signals or keywords is done using natural language processing techniques and large language models. And then after that, we go for the signal identifications. What are the signals? And also within that process, we do have some clustering combination of the similar signals to avoid like slight changes between the different signals, how to avoid missing important signals if they are like very similar, but like overall they are different. And then at the end, the next step is like identification of weak signals. As I said, that's based on the degree of emergence or degree of growth. And the last step basically incorporates the expert insights for categorization and bringing the signals in the higher level or broader level for communication and presentation, which also this step includes some ideation from the large language models. But of course, for getting better accuracy and more precise result, we need to have the expert review and the sanity check for identification of the key emerging area under water network. And next slide, please. So as you see in this radar chart, this is the basically we concluded to have the signals under 4 main categories, which are data, technology, analytics and modeling, and application area, which is suggested by expert review over the emerging signals. And as you see from this kind of journey from weak signals, which are called here as nascent signals, and then there are pervasive signals that they have still low low intensity, but they have higher dissemination. And then the next step is for concentrated signal, that they have higher intensity. And then the last one is the dominant signals, which are strong signals, or basically they are very strong in for their dissemination and also prevalent or intensity. And like next slide, please. Basically, using a large language model, we ended up with this kind of categorization for the signals. And as you can see, like you can see the title of the signals as well as the description of the signals under each category, if they are dominant signals, or concentrated signals in different categories. For example, this one for analytics and modeling, we have analytics hierarchy process signal as a dominant signal, or artificial neural network as a dominant signal under this category. And the next slide, please. Yeah, it is. This one is also another example for technology, for the technology categories. For example, hydrothermal method or cloud-based or geospatial techniques are identified as pervasive signals under the technology category. And in the last slide, which is the next one, we also present the different categories, how they come under water network context. Basically, we ended up with about 800 signals for all the categories under water network context. But of course, not all of them can be categorized under this for particular categories. But as you see that analytics and modeling, it has the greatest number of the signals for greatest number of weak signals. Although like strong signals are more observable on application area and then after technology categories. So basically, it was brief overview of our methodology based on the large language models for identification of emerging trends. And as I mentioned earlier, the aim for this methodology is less intervention or minimizing the manual work from the expert review if we want to highlight the contribution in theory and the practice for this methodology. Thanks for listening, and please feel free if you have any question regarding this. I will be happy to answer in the Q&A section. Thanks.
Perfect. Thanks a lot. This is bringing us close to the end of our webinar today. I'm Michael Hanf. I'm a lead sustainable business at VTT, and I have the pleasure to ask all the questions you have. So if you have questions, please type them into the chat. So far, there's no questions. So I have the privilege as the one leading the panel discussion to ask the first question. Now, throughout the presentations, it became very apparent that data, the smartness of the network, of the water network, is very important. And it's becoming more and more important as fresh water is becoming more and more of a topic in many parts of the world. Living in Finland, we have the privilege of opening up the tap and fresh water coming out. But in many parts of the world, we don't have that. Now, to me personally, my experience is that the utilities industry and the different stakeholders are partially rather traditional. They're not necessarily utilizing data and these smart technologies very broadly. So I would be interesting in hearing from Pipelife, Keypro, and Elisa, what is your experience on the adoption of the solutions? And then also from Sajat, like what were some of the outcomes when you did the analysis of the signals? What were some of the key signals you saw when it comes to basically the utilization of this new technology? Nora, do you want to maybe start?
Yes, thanks a lot. I think that's very important question, and I think this utilization of the data was also the starting point in this project for us, that it's not only about making data move or making it possible for the data to move, but also to understand that how we need to do it so that the water utilities really take it into the utilization. Like you referred that some of the companies and are not so like technologically oriented, or are not so far ahead yet. And I think the main idea is to understand that what is something that the user already now uses, and put the information visible there. So not maybe pushing users to adapt to new systems or new technologies. Instead, just kind of enhancing what they currently use, and make that use case something that they feel that now this helps me. When a user understands that, okay, now we have done some demo and this really helps me, then it's easier to go forward. So this is how I see it, and this is how this kind of ecosystem really works, because then you don't need to adapt to something totally new. Instead, you enhance what you already do every day. So that's, I think, one aspect. Thanks.
Yeah, no, makes perfect sense. Thanks, Nora. Marco, you mentioned the sensors and how you're using sensors to collect the data, which is naturally something that needs to be implemented and needs to be taken into use. So also to you, the question, how do you see the adoption of these smart technologies in the context of the solutions you have been developing?
I see a bright future in the adoption of the solution, because some part the solutions that we bring or we that our customers are adopting are the basic foundations have done already in the 90s. So the standard controlling and monitoring foundation for the utilities are from the past automation technologies and from the industrial automation. Of course, that is more like closed systems, and the beauty of the API and the beauty of bringing new more IoT-based sensoring. Of course, it is the information that in addition to that we are able to provide. So basically, there isn't a challenge of adaptation. There's more of a challenge of how to integrate, how to combine data for the customer in a way that it brings value, like Nora brought it out. I think and again, the innovation is founded, or the innovation is created between the interlinkages of the networks and not actually within the network. And when we are able to open up our systems or define together that, okay, your role is more from the NIS GIS world, our role is from the ditch and from the assets to provide the information, and if we are all understand, and if our all value creation fits to that, then we are able to succeed. But if there's a reasonable doubt, or that we are not transparent for our motivations, then we can be challenged. But in generic, the technology enables, the customers are getting more aware, and they have been using these technologies already for decades. So I see the future bright.
Perfect, makes sense. Thanks, Marco. David, how do you see it from a network point of view?
Purely from the network point of view, if looking at NB-IoT or LTM at water utility sector, that is not used very widely yet. So that it's something that's going to, and it has been increasing a lot already, but it still isn't very widely adopted and not very widely used. So I really believe it is important to tell that what these technologies can bring to you now, as many water utilities are on the position that they should choose what to install, what communication technologies to use, what kind of sensors to use, and it's always connectivity is somehow part of it. Either it's wireline traditional old connectivity, and then it is somehow transmitted to the SCADA system or some other system, or then it is new IoT connectivity standalone that is then used to connect the new devices. But that's not really, the IoT connectivity isn't really widely adopted yet, I would say.
Perfect. Thanks, Savi. Unfortunately, we're out of time. We're at the top of the hour. So sorry, Sajat. Can unfortunately not give you a chance to talk about the key findings. But if we can share the last slide, there is my contact information on that slide. So if you have any questions or if you're interested to hear about the findings that we took out of the Future Radar, what are the key trends that we're seeing, please feel free to drop me an email, drop me a note. We're very happy to schedule a follow-up meeting with Sajat, with Caroline, with Mona, to talk about that in more detail, as we're basically looking to bring, as many of the speakers said, bring these solutions into real life to maximize the impact out of the work that was done in this project and make sure that the water network becomes smarter going forward. The only thing left is for me to thank all of you that you joined the webinar today, and to thank all of the speakers for the great presentations. Feel free to reach out to the speakers, to myself, and have a great day. Thank you.
Thank you from my part.